Hi, everyone. This is part two of the pre-assessment for the final. So let me show your screen and we will go from there. All right. So for number 4, this is a rational expression. We just went over this. This is 3, and then you factor out the x minus 4. And on the bottom, you're going to go x minus 4, x plus 4. And what you do here is you cancel it out. Again, you factor everything you can, and then you're going to graph x3 over x plus 4. And when you graph this here, remember the whole is at x is equal to 4. So let's graph this first before we graph the whole. We have the vertical asymptote at -4. So 1, 2, 3, 4. Then we have the horizontal asymptote at 0, right? Because the power on the bottom is bigger than the power on top. Okay, and what we're going to do is we're going to plug in numbers on the right and left of the vertical asymptote. So maybe we should plug in -3, -2, 1, 0. That should kind of give us a good clue on what's going on. And then -5, -6, something like that, -7. That'll give us another clue. Okay, so if we plug this all in, it'll be 3. Let's start with a -3 plus 4. That equals 3 over 1, which is 3. So 1, 2, 3. All right, let's plug in -2. So 3 to -2 plus 4, it's 3 over 2, which goes down this way, 1.5. And you can see this the graph right here coming down this way. All right. And remember that x at 4 is a hole right there. So just make sure you draw that out. Okay. All right. And then with the -5, 6, and 7, so 3 over -5 plus 4 will be -3. So 1, 2, 3. And then it'll probably be 1.5 at 2. And it'll probably do something like this. Okay. Cool. All right, I think that's it. I don't think you need the intercepts because the x-intercept is the horizontal asymptote. I remember what I said before about the asymptotes for rational expressions. I mean, sorry, the intercepts of the rational expressions. Sometimes you may not be able to get it just because the asymptote lies on the y equals 0 line. Okay. All right. Number 5 is x squared radical 150x minus 9x radical 54x cubed. A lot of you guys struggle with radicals, and I encourage you guys to continue to practice them. But this is x squared, and then times, if you split this up, let's go radical 150, let me erase that. So radical 150 is 25 times 6, and radical x. So radical 25 is 5, so it'll be 5x squared radical 6x. And if you do this, it'll be 9 and 6. So it'll be minus 9x radical 9 radical 6 radical x cubed. So it'll be minus 9x. This is times 3. And then you could take out 2 here, so it'll be another x. And then there's 6, and then there's 1 remaining because I took out 2 of the 3. So when it comes down to it, it's 5x squared radical 6x minus 27x squared radical 6x. And because they both have an x squared radical, they're like terms, you could combine them. It ends up equaling negative 22x squared radical 6x. All right. For letter B, I would put it in fraction form. So it'd be k 9 over 4 over k 7 over 5. And when you're dividing, you're subtracting the exponents. So it'd be k 9 over 4 minus 7 over 5, which is 20. The common denominator is 20. So it would be 28 up top here. And then that's 5. So it'll be what? 45 here, so it'll be 17 over 20, so k to the 17 over 20 power. All right. Number 6, you have negative 12 minus 12i over negative 4 minus I. Multiply the top and bottom by the conjugate. So this will be on the bottom, it will be 16 minus 4i plus 4i minus I squared. On the top, it will be 8 minus 2i plus 48i minus 12i squared. When it boils down to it, let's see here. We have this is 46i. This is positive 12, so that's 20 plus 46i over, these cancel out. This is negative 1, so that'll be plus 1 over 17, and that's your answer. Okay, letter B, fourth degree polynomial. So you have the roots, so it's y equals a and then x minus r, which is negative 2. X minus 2, x minus I, and x minus negative I, which is x plus I. And what you're going to do is x plus 2, x minus 2, x minus I, x plus 5. What you're going to do is you're gonna multiply these two and these two. I think that's easier because you're kind of like, yeah, it's kind of like combining like terms, because this is like x squared minus 4, if you recognize that right away. And this is x squared minus I squared. But I squared is negative 1. Negative 1 makes this positive. So it becomes x squared minus 4 and x squared plus 1. All right. And then you multiply it out. Well, you could then bring in the a. You try to look for the a, and the a is you have to make x equal to 3. All right. And y equal to negative 150. So plug it in here. We negative 150 equals a, and then 9 minus 4 and 9 plus 1, because I'm just plugging in the 3's into both. So it becomes negative 150 is equal to a times 5 times 10, which is 50. So negative 150 is equal to 3a. A is equal to 50. So a is equal to negative 3. Once you do that in factored form, it's y equals negative 3, x plus 2, x minus 2, x minus I, x plus I. If you do it in standard form, I would do it from here. Y is equal to a, and then x squared minus 4 times x squared plus 1. You have to FOIL this out, so this will be x to the 4th plus x squared minus 4x squared minus 4. And then the a is negative 3. Y is equal to this. Then distribute the negative 3 into these. So it'll be y is equal to negative 3 x to the 4th minus 3x. So this is what? This is minus 3x. So this will be minus 3x times minus 3x will be positive 9x here. Apologize for that. I was supposed to combine this term and this term, that's negative 3x squared. Multiply that out. That'll be plus 9x squared minus or plus 4. So this equation, if we combine line term, y equals negative 3, I'm sorry. It's x to the 4th minus 3x squared minus 4. And then I distributed the 3 to get this in standard form. All right. That is number 6. Number 7 is rational functions here. Again, you want to get the common denominator. So the 2x needs an x minus 6. The minus 7 does not. And the x needs an x minus 6. These are all trying to get the common denominator. So you distribute, it'll be 2x squared minus 12x minus 7 equals x squared minus 6x. So I want to make this a quadratic. So I want to put it in standard form, and this is where standard form is important because you want to make everything equal to 0. So it will be what? X squared minus 6x minus 7 is equal to 0. So you factor x minus 7, x plus 1. So our answers are x equals 7 and x equals -1. All right, piecewise function is, let me do this here real quick. Let me draw this out. All right. So let's maybe graph this. We have 8 spots here. So we want 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4, 5, 6, 7. So you go, so from this right here, it is -1. Let's plug in the -1 because you just want it from -1 to infinity. So you just want it from right here, and you want it to go this way. So here we go. So y equals negative and then -1 minus 2. Y is equal to 1 minus 2, which is y is equal to -1. So -1 is right here. Okay. And then just get another point in there, and it has to be on the left side because remember we're going to negative infinity. So let's just go y equals -2. So -2 minus 2. This will be +2, and this is going to be 0. Right? So it's going to be a open circle. So I should erase this circle. Open circle going this way. And then from x squared plus 3, we know that it's a parabola, right? But it's at the y-intercept is 3. So we go to the -1, plug it in, -1 squared plus 3, that's 1, so it'd be 4. So -1, 4. So 1, 4 would also be another point. And then if you plug in 3, 3 squared is 9 plus 3 is 12. So you go up this way. So it should look something like this. This should be a open circle. This should be the open circle, but everything else is good. And then from there, y equals 2 as a horizontal line from 3 to 8. And so at 3, draw open circle and go all the way to 8. And that is your piecewise function here. All right. If you have any questions, let me know. Thank you for watching. Good luck on the final.